Do you know what extending a class means? Have you called a superconstructor before? In this video we are going to dive deeper inside the object-oriented approach. Follow along to learn how to do this yourself. Hello and welcome to part 26 of the series on how to create a chess game with Reactjs. We are going to pick it up from where we left last time. In our source folder we have the position, and the last time we have created a function on the position which is samePosition. So on the class position, we have a function samePosition, which has a parameter otherPosition, and this otherPosition will be compared to the position which it is being called on, and then it will return a boolean, and it will return true if the position is the same, or false if the position is not the same. If we open up our constants, we have exactly the same function, but this function, instead of having it on the class, we have it just as a separate function, not related to anything. And this function accepts two parameters, a position 1 and a position 2. It returns the same value, which is if the positions are equal, true, and if the positions are not equal, false. But as you can see, it takes two parameters, position 1 and a position 2. In this function, the samePosition, it only takes one parameter, the otherPosition, because we have the position where we call it on already. Alright, so we want to implement this and we want to remove this. So let's first of all remove this and save it up. Now, if we refresh the page, we should see some compiler errors because we have a lot of components which don't, which use the reference of the samePosition. So if we open up our components and then the referee, inside of here we see that we get an error already. samePosition is not found. Well, we can just remove it from here, and then we can fix all the errors down here. So instead of saying samePosition piece.position bladePiece.position, we can say piece.position.samePosition, like so. And then we want to pass in the second position, which is the bladePiece.position. So we say bladePiece.position, like so. And right now, this should, we also need to remove this samePosition. And right now we have the first function, the first samePosition occurrence rewritten in our new syntax. So before we had only the samePosition, and then we pass in two pieces or two positions. And right now we have a piece, and then we access the position of the piece. We call the samePosition function on this class. So we call this function right here. Then we pass the bladePiece.position. So this position is getting passed. So this other position will be the bladePiece.position. And then it will execute this code, which will return true or false, depending on if the positions are the same or not. So right here, we also have a position. So here we want to say if piece.position.samePosition is not equal to, and then we pass in a new position of destination X, comma destination Y minus pawn direction. It's all good. Then right here, we want to say piece.position.samePosition, and then bladePiece.position, right? Then down here, we have the piece.position is not equal to new position, which is the destination X and Y. And then down here, we have another occurrence of the piece.position.samePosition, and then we can pass the new position like this. So we can save this up. I don't think it will work yet because we also use it quite a lot in some other files. So we also get an error right here. Oh, in the pawn rules. So that's normal. We still need to fix that. But before we are going to do that, we are going to enhance the samePosition function. And you might think, well, how are we going to enhance that? we just created a function on a class, which is the position class. Well, we are going to do that by adding this logic to the piece as well. So if I go to the first occurrence up here, I think it's this one. So if we go and press search, we see that the first one is up here. We have piece.position.samePosition platePiece.position. So what does this actually mean? This means that we want to know if this piece position has the same position as that piece position. But we can write this shorter, and we can do that by making the pieces more intelligent. So if we go to our piece class right here, we are going to add a function to here as well. So we say we don't need to write function. We're going to say samePosition, and then we get a parameter which will be other piece, which is of type piece, and this will return a boolean like so. And then what this function is going to do is it's going to compare the positions of two pieces to see if they are equal. So right here we want to return this piece.position. So we say this.position dot samePosition other piece.position. All right. So we have a little bit of confusion going on because we have the samePosition function on the piece, and we also have the samePosition function on the position. Okay, so to clarify, on the function or on the position, the samePosition function compares two positions, and the positions can be from anything. So the position could be from a piece, but say if our application got bigger, it could also be the position of something like a button or anything else. It's just, it needs a position. Right here in our piece class, we also have the samePosition function, and this accepts a parameter of piece. So this samePosition function will only compare the positions of two pieces. So we cannot compare two button positions, for example. This is only for pieces. And inside of this function, we do use the samePosition function on the position class, so we don't need to write duplicate code, but we spare some code by adding this functionality to our piece. All right, so let's save this up, and if we go back to our referee, we can apply it right here. So here we have piece.position.samePosition platePiece.position. This is going to be written like this. We can remove the position from here, and we just say piece.samePosition platePiece. So it also makes it a lot more readable. Does the piece have the same position as the plate piece? And then the parameter that gets passed on in the function is the plate piece. So if we go inside of here, we execute this function, the other piece will be the plate piece. And then right here, we say, okay, the position of this piece, is it the same as the position of the other piece? And that will in turn execute this function. So now that we have fixed this one, we can also apply this to the other places where we use the samePosition. So right here, it's a different story because we have a piece.position, but right here we compare it to a custom position. So what we can do is we can create an overload for the function. So in our piece class right here, we have one function for samePosition which accepts a piece as parameter, but we can also add another function which accepts a position as parameter. As you can see, we cannot have two functions with the same name. We are first going to complete the bottom function. So we're going to write exactly the same code as above, but instead of saying other piece.position, we say other position, like so. And then we are going to alter the name of this position or of this function. We are going to say samePiecePosition because we are comparing a piece, And here we say samePosition because we are comparing with a position. Right here, we need to add piece. So if this piece has the same piece position as this piece, then we execute this code. Then we can scroll down to here. And then we can say if piece has the same position as that piece. So this will also be a samePiecePosition. And I thought that we had a position somewhere right here. Yeah, exactly. This position, if this piece has the same position as that position, then we want to execute this code. So right here, we can use the samePosition function because we pass a parameter of type position. If we look inside the piece, the samePiecePosition accepts a parameter of piece. samePosition accepts a parameter of type position. So right here, samePiecePosition, we pass in the played piece. And right here, the samePosition, we pass in a position. Right? So down here, we are comparing a piece with a position. So we can say piece.samePosition. That's fine. Then down here, we should have some more. So if we go for samePosition, that was the one that we just fixed. And then down here is the final one. And we want to compare two piece positions, I think. If we remove this one and then we say samePiecePosition, we can remove the dot position from promotion pawn. So we get piece.samePosition as promotion pawn. Great. Do we have any references in the chessboard? Well, we do have a couple of them. Let's do this one together. And then I'm going to fix the rest of the references inside of the referee. So right here, we want to see if we have the same piece position as the grab position. But we can now use our newly created function, which will be p.samePosition of the grab position, like so. And we don't need to use this function anymore. Right, so down here we compare a piece position to a new position. So we say p.samePosition, and then we pass in a parameter of new position. What we could also even do is create a new function on the piece which accepts an x and a y. So we don't need to pass in a function, but we pass in I, j in this case. But this should be fine for now. And then right here we compare two positions with each other. So here we say p.samePosition and then new position. That was the final one, I think. Up here we also have a p, but this p is from the piece. So we say p.samePosition and then the grab position. So let's save this up. This file doesn't have any errors in it anymore. Let's refresh the page. We still have some errors in the pawn rules. I'm going to fix those and I'll be back in a second. We fixed every occurrence except for in the queen rules. So in the queen rules, we still have one left. If we make this a samePosition from the passPosition class, then we should have a working program again. General rules, also very important. We can remove this one and then we still get two errors. One little trick I'm going to show you once again is, as you can see, the samePosition function call is exactly the same. We pass in a p position and a position. If we press Ctrl D on this one, p.samePosition, and then we can remove p.position, and then we can put position like this. So we have fixed two occurrences at once, and our chessboard is working again. Let's test it out by playing some moves, testing out if the enPassant is still working, which it is. Can we still promote pawns? We can also still promote pawns. Great. Now that we have fixed the positions, we are going to create a new file, and this new file will contain all the enums. I'm going to close the files that we have up here, and then minimize everything. And inside of our source folder, we are going to create a new file, which will be Types.ts. And inside of Types.ts, we are going to put the enums. So we're going to cut them away from here, and we are going to paste them inside of here. Let's save this up. We need to import the enums from types. So we can save this up. And we need to fix the references. So inside of our referee, we don't need to import the types from the constants, but we do need to import them from the types. So let's see, if we press team type, it should automatically recognize it. So now we imported it, and if we look at the top of the file, we can see that the pieceType and teamType have been imported from //types. So // is inside of here, one up is in the source, and then in the source folder we have the Types.ts. Once again, I'm going to fix the rest of the occurrences. Import them from, not from //types, but from //types. So we put one too much. The reason why this doesn't work here is because the models are directly inside of the source, and the referee, for example, is not directly inside of the source. It's indirectly, or not indirectly, it's a subchild. So first we have components, and then we have the referee. So now that we have fixed this, we can save up this file, and then it should work. Great. One thing that I changed as well is inside of the pawn rules, we also had a pieceType. We removed that import because we didn't need it. We can remove this import as well. And I saw one import in the rook, or was it the bishop? No, the knight, king, pawn, queen, somewhere. Yeah, okay, so it was the bishop. We had an import for reducing each trading command range. We don't need that, so we can remove that, and it will still work as expected. Great. So, great job. We have created a new file for our enums. And now that we have that, we are going to continue working on the piece class. The piece right now, if we open it up, has a lot of properties and also some functions. We are going to add a couple more functions. The functions that we are going to add are going to determine what type of piece this piece is. So the first function that we're going to add will be isPawn, and this will accept no parameter, and it will return a boolean. And it will return a boolean based off this.type is equal to pieceType .pawn. And we can even use an arrow function instead of the curly braces, but it's fine for now. We have a function isPawn, and this will only return true if this pieceType is of type pawn. We are going to copy this over down here, and then we say is rook, and this will return true if the pieceType is rook. We will have a function which says is knight. This will return true if the piece is a knight. Then we'll have a bishop. And the reason why we are doing this is because we can more easily determine the type of the piece. And we are also going to implement a new class or a new class for the pawn. So the pawn is a special piece because the pawn has a property named enPassant, which right now all pieces have, but not all pieces can enPassant. Only the pawn can enPassant. So you don't want this property on all the pieces. You only want this property on the piece if it is a pawn. In order to achieve this, we can create another class, and this class will be pawn. And inside of this pawn file, we are going to create a new class, pawn, with a constructor, like so. And this constructor will be empty. If we open up our piece, we need to export the class as well, because otherwise we cannot use it anywhere, like so. And if we look at the piece, all the properties we see right here are also part of a pawn. If we take a horse, then not all the properties are part of that horse, because this property, the enPassant property, is not part of the horse. So in order to remove the enPassant property from the piece and only apply it to the pawn, we can take it from here, which will again cause a lot of errors, and we are going to put it right here. But now you might think like, okay, we have the enPassant property, but what about all the other properties? The pawn doesn't have any other properties, for example, the image, the position, the type, the theme, or the possible moves. One thing that we can do is we can just copy them over as well. So we can put them on the pawn like this, and we can start rewriting all the code that we have already written. But that is not a good idea. Instead, what we want to do is we want to say this pawn extends from the piece class. So what does extends mean? Extends means that the class that we put right here on the right side is the base class for this class on the left, for the pawn class. So we cannot find an in piece. We need to import it, which is great. So now we have this. We get another error because if we extend from a base class, let's see what it is called right here. The constructors for derived classes must contain a supercall. That's right. The pawn is a derived class from the piece class. So we need to call the piece constructor right here. So let's see how we do that. We call super. So I think it's written like this. Yeah, so here we see that we get the option to pass a position, a piece type, and a theme type. If we look at the piece, we see that we have a constructor which accepts a position, a piece type, and a theme. So essentially, we are, wait, now it's gone. Essentially, we are calling the constructor of the piece inside of the pawn. That's great because then we can pass parameters to this pawn or to this piece. One thing that might be important to understand is that once you extend from a class, so once you extend from, in this case, the piece class, you also inherit all its properties. So if I say right here, this dot, we will see all the properties and all the functions as well that are defined on the piece. And also up here, the property enPassant, because this is defined on the pawn. But we also see this.image. So if we remove this and we say console.log this.image, we get an error because it says, hey, super must be called before accessing this in the constructor of a derived class. Okay, that's fine. So we put the console log behind the super, then it will work. Right now we have access to this image because the pawn extends from the piece class. I'll show you it in a second, then it will become more clear. We are going to look at the logging in the console, and then you'll see more in depth how this works. So right here, we want to call the super class, and we need to deliver a position, a type or a type, and a theme. So we are going to add a position to here as well. which is of type position. Then we are going to add the type as well, so type, which is of type pieceType. And then we are going to add one more thing, which is the theme, which is of type themeType. Great. So now that we have those parameters inside of the constructor of the pawn, we can pass them on into the constructor of the piece. So we pass on the position, type, and the theme. We get no errors anymore. And we have successfully created a pawn class. Well, almost successfully, because we can improve it by one little thing. If you want to try this out yourself, try improving the pawn. And to be clear, it's the part that we are going to improve is in those two lines, the constructor, actually only this line, the constructor. So in this line, we're going to change something which will shorten the code and kind of improve the code overall. All right, so the thing that we are going to change is this. Right now, we pass a position, a type, and a theme. Position makes sense because, well, the pawn can have any position. The theme, so that's the last parameter, also makes sense because it could be our pawn, it could be their pawn. The type, however, doesn't need to be passed in as a parameter to the constructor because the type should always be pawn, right? We will never have a pawn class of type rook or type knight. No, we will always have a pawn of type pawn. So instead of getting or requesting the parameter inside of the constructor and then passing it on to our piece constructor, we are going to hardcode right here, pieceType.pawn, and that makes only two parameters inside of our pawn constructor. All right. Now that we have this, our class is ready to be used. So we don't get to see the program running yet, but however, we are going to fix that first. If we go inside of the referee, we see that the enPassant is not a property of type piece. Well, to be fair, that's true because it is no longer part of the piece. Before we are going to do this, I really want to show you how the pawn or how the pawn can access the properties of the piece. So for now, I'm going to comment out all the errors and I'll be back in a second. Alright, I fixed the errors by just commenting out every place in the code which uses the enPassant property. It's not a good habit, but we are going to fix that later. What we can do now is we can open up our program and we are going to open up the console. And inside of here, we are going to look at the output inside of the console. So first of all, let's open up the piece. Because inside of here, we are going to add a new log, which will say entering the piece constructor. We don't want to have an indent on this, so we remove this. We are also going to say leaving the piece constructor, because right here we are done. And one important thing to notice is that we want to, let's see, what did we want to print right here? The image. So right here, we want to also print the image. And since the image consists of the type and the theme, we are going to write the console.log after the image has been assigned. So we say console.log image, and it should be this.image. Otherwise, we will get compiler errors. If we save this up, we should see a lot of logs because we have a lot of pieces going through the constructor. We don't want to see any of them actually. We only want to see the pawn. So inside of our constants right here, what we are going to do is we are going to select everything except the first pawn. It's a lot. Yes. Then we are going to press Ctrl// to comment it out. We are going to remove this comma because it's no longer relevant. We're going to save it up and refresh the page. And we only see, oh, well, this is a rook. That's not the piece that we are looking for. So we can comment this rook out. We're going to search for a pawn. What's the first pawn that we see? The first pawn is right here. Great. So we can uncomment this. No, we can uncomment this. Yes. And then we can save it up. So now we should see one pawn. We need to remove the comment. No. We need to remove this. Yes. So I added a little bit too much by accident. All right, so now we have one pawn. We see entering the piece constructor. So we are going inside of the piece constructor right here. We get the pawn image, which is assets, images, and this. And then we say leaving the piece constructor. However, we don't see this console log. And for the full clarification, we are going to add entering pawn constructor. And then right here, console.log, leaving pawn constructor. So let's save it up. And we see entering the piece constructor. We see the image still, and we see leaving the piece constructor. However, the pawn constructor is not being called. Well, that's because we don't have a pawn class instance yet. Inside of our constants, we have a piece instance. So naturally, only the piece constructor will get called. We want to change this to pawn, like so. Then, as we know, the pawn only takes 2 parameters. The piece type is not required anymore because we know that this is a pawn. We can remove that from here. Then if we save this up and look at the console, if we refresh the page, we get an error. Why is this constants.ts expected to, oh, okay, we need to resave it and refresh the page. And if we look at the console, we are going to follow the logging. So entering pawn constructor. Let's open up the pawn. We are now right here, entering the pawn constructor. Then we are entering the piece constructor. But how? Well, because we call super right here. If we go inside of super, we get inside of the piece constructor. And then we are hitting this console.log. Do you see that? We are going first inside of the pawn constructor. We are right here, but then we are calling the piece constructor. So we are going inside of here, and we are entering the piece constructor. So inside of the pawn constructor, we are executing the piece constructor. Might be a little bit difficult, but we are executing 2 constructors at not the same time, but after each other. And once we are inside of the piece constructor, which is right here, we are logging the image, which is this. Then we are leaving the piece constructor, which is here. And then we go back to the pawn constructor since this line of code has ended. We are logging this image, and the pawn has access to this image because it extends the piece. As you can see, we get exactly the same value as we got inside of the piece class when we logged it. And then the final thing is we are leaving the pawn constructor, and we get that logging as well, leaving the pawn constructor. So that's how this works. We can, by creating a pawn class, we can omit one parameter, which is a piece type. We also don't need to define all the properties on the pawn anymore because we extend from the piece. And the final thing is we only need to apply enPassant to the pawn and not to the piece anymore, which is a huge win because that means that it is not possible to create an enPassant move with another piece anymore. So before it also was not possible because we have coded it that way. But if you would want to, well, you could make any piece enPassantable. Right now it can only apply to the pawn, which is what we wanted. Alright, so now we have this pawn class. What we want to do right now is we want to use it. So in our constants, we can uncomment everything up here, uncomment everything down here, like so. Oh, that was not what we were trying to do. Maybe if we select it again, hopefully, yeah, great. So I just selected everything and then press Ctrl// and that will uncomment everything. All right, so first of all, we have the rooks, the knights. We only want to change the pawns. So we already did this one. Now the next piece right here, we can change piece into pawn and we can remove pieceType.pawn. And let's try and do this a little bit more efficient. We're going to select every occurrence of pieceType.pawn. Great. Then we press delete, delete, backspace, backspace. Then we press the arrow up once, arrow left once. Then we press Ctrl and backspace to remove a whole word. And then we type in pawn. Save it up. And boom, we have everything as it was. We use the pawn constructor right now. We have removed, 16 lines of code because we don't need to pass in the piece type anymore. And it still works. Well, almost. I'm still going to fix the chessboard because I've commented a couple of things out. So I'll be back in a second. Alright, so I've brought back the code that we have created, and I have also brought back the errors that we got when we removed the enPassant property from the piece, which is normal because we don't have it on the piece anymore, it's on the pawn right now. We are going to fix those, and in order to fix those, we are going to use the new functionality that we have built onto our piece, which is the functionality to determine if the piece is a pawn, a rook, a knight, bishop, king, or a queen. We're going to open up the referee, and right here we get an error because it says, hey, enPassant is not a property of piece. If we take a closer look at this code, we see that right here we have the active piece. So if piece.samePosition of the play piece, then we want to do some things. So the play piece will always have an enPassant of false. This is no longer the case. We only want to say that the enPassant is false if the piece is a pawn. We say piece.isPawn. If piece is a pawn, then we say piece.enPassant is false. And in order to remove this error, we are going to cast the piece to a pawn class. So right here, we say piece as pawn. Then we get an error because we cannot find pawn. We can import it like so. .enPassant is false. Great. So now we have successfully refactored this piece of code, and we only want to execute this if the piece is a pawn. So we indent this like we should. We are going to refactor one small thing, which is the function to say, hey, is this a pawn or a rook or a queen or something else? Right now we need to add parentheses. We can remove that by going inside of our piece and making this a getter. So we say get is pawn, get is rook, get is knight, get is bishop, is king, is queen. We're going to save this up, and then right here inside of the referee where we were, we can just omit the parentheses, and this will be a property. So a property is something like what we have up here, but instead of having a, well, how do you call it? A predefined property, we have a calculated property. So we cannot pass variables to this, I think. So let's say text is equal, which is a string. Then it will say a get accessor cannot have parameters. Great. So this getter, this isPawn, is actually a property, but then on steroids. We cannot pass parameters, which is okay. But instead of predefining this variable right here, up here, or inside of the constructor, we define it on the go. So this is calculated when we request this property. And because we add the get keyword, we don't need to add the parentheses to it anymore when we call it. Before, we didn't have the get keyword on the left, and then we did need to add the parentheses. But right now it's a property because we added get and we can omit the parentheses. Here is a perfect example of where we can use it. If piece.type is equal to pieceType.pawn, if piece.isPawn, then we say piece.enPassant is false. Then we need to change this to piece as pawn.enPassant is false. Then right here we say piece.enPassant is equal to that. Do we know if this will be a pawn? That's important because we don't want to cast the piece to a pawn if we do not know that the piece is actually a pawn. So let's see right here, special move, samePosition play piece. Yeah, so here we need to add a check that is pawn. Then we want to execute this code right here. And then instead of saying piece, we say piece as pawn.enPassant is equal to this. Great. Then right here, if piece is pawn, this is beautiful because we can just say is pawn. And then right here, we can say piece as pawn.enPassant. And then down here, we want to check if it has an enPassant. So let's see. If type is equal to pieceType.pawn, how do we determine the type? Okay, so the type it gets passed on. So we cannot say isPawn because we don't have the piece right here, which is fine. But let's see, we do know for sure that this will be a pawn. We are looking for a piece that has the enPassant on true, I think. But just to be sure, we want to know if this piece is a pawn. So we say p.isPawn, like so. If the piece is a pawn and the pawn has enPassant enabled, and we can omit this parentheses because it will only evaluate this if the piece is a pawn. If this results to false, it won't evaluate this right here. And then we can put this on the next line, like so. Now, if we save this up and refresh the page, we should still have a working application. So let's move some pieces. Let's take this horse. Let's move the queen. Put it right here. Then we move the king. Move this queen. Yeah. So we still have a working application. And what we did right now is we have enhanced the code. We have refactored the code into being more object-oriented. So we have a pawn, which extends a piece. We have added extension to our code. We have called the super constructor. We also have some neat functionality to determine what the piece type is of a pawn. And we have also refactored the constants into a smaller and more compact version by using the pawn constructor or the pawn class. And we have also refactored all the code that used those references. That's it for this episode. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!